Today's lesson is a continuation from yesterday's section 1.2 on functions. The first thing that we're going to talk about today is when does a function increase, decrease, and is constant. The example I have here on this slide is, for the first part, the function is increasing because it is going up. It is then decreasing, and then at the end it is constant. In your homework, you'll be asked to graph these in your calculator and determine what intervals these are increasing, decreasing, or constant. We are talking about the x values. So if I labeled this as, let's say, -3, and over here, let's say, was -2, and let's say this was -1, we would be increasing on the interval from -3 to -2. We would be decreasing from -2 to -1, and we would be constant from -1 to infinity. Again, these are x values, what we are looking for here. Next, we are going to talk about if a function is lower bounded, upper bounded, or both bounded. If it is bounded below or lower bounded, it will have a bottom or a minimum. And again, looking at the graph, you can see pretty easily that this is going to have a lower bound. The second one has an upper bound because it does have a max. The third one has both an upper and a lower bound, so it is bounded both above and below. Again, you'll be looking at graphs and determining what type of bound these graphs will have. The next thing we're going to talk about is local and absolute extreme. A local min, or max in this case, can happen anywhere a function goes from increasing to decreasing. So at this point here, this is a local max. The absolute max is up here because it is above where the other local max is at. We are looking at y values when we're talking about max and min, because we're talking about the vertical change that the graph has. So here's an example of two maxims. One's absolute and one's a local. Just like this example, we are going to find local mins and absolute mins. Using our calculator, we're going to be able to find both of these. We will review this in class if you have forgotten how to use your calculator to find max and mins. Symmetry is the next concept that they want to talk about. An even function has symmetry with the y-axis. So if you look at the function I have here, which is f of x equals x squared, it is the same to the left as it is to the right. If you can imagine folding the function along the y-axis, it would match up. Another way to look at it is this function notation here. So if I plug in x, let's say 2 or -2, it's going to have the same value. If you plug in 2 here, it's going to be 4. If I plug in -2, it will also be 4. That is another way to look at even functions. Odd functions has symmetry with the line y equals x. This is the dotted line y equals x here. X to the third is an example of an odd function. And you might ask yourself, does the power have anything to do with being even or odd? And yes, it does. If it has an odd power, it is going to be an odd function. If it is an even power, it will be an even function. Notation is right here. If the function, if I put a negative sign in the function, it is equal to when I put a negative sign for x. Horizontal asymptotes. My dotted line here is an example of a horizontal asymptote. This is where the graph approaches but doesn't quite touch the line. We describe horizontal asymptotes as y equals whatever number that it crosses the y-axis. So if this crossed it at 2, we would say this horizontal asymptote is y equals 2. My example here is a function that has a horizontal asymptote at y equals 2. At this point, we are just going to be graphing these on our calculator and locating them. We will learn other ways algebraically as well to find asymptotes. The last one that we are going to talk about is a vertical asymptote. Vertical asymptotes are very easy to find. They are where the denominator is going to equal 0. In this case, x plus 5 equals 0, x equals negative 5 is going to be our vertical asymptote. X equals a number is the way we can describe a vertical line. And as you can see, this graph approaches negative 5 from the right. From the left it goes up, from the right it goes down. This is the homework that we'll be working on tomorrow, page 98, 27 to 63 every third.